Good day. I am back again with another concepts video about our last topic, which is productivity, measurement, and control. So first, let me define to you what is productivity. Productivity is concerned with producing output efficiently and it specifically addresses the relationship of output and inputs used to produce the output. Then we have total productive efficiency. Total productive efficiency is the point at which two conditions are satisfied. The first condition is for any mix of inputs that will produce a given output, no more of any one output is used than necessary to produce the output, and it is driven by driven by technical relationships and requires eliminating all non-value added activities and performing value added activities with minimal quantities needed to produce the given output. So the first condition pertains to the technical efficiency. Now going to the second condition, which is given the mixes that satisfy the first condition, the least costly mix is chosen, and it is driven by relative input price relationships. Input prices determine the relative proportions of each input that should be used, and the second condition pertains to the input trade-off efficiency. Technical improvements in productivity can be achieved by using less input to produce the same output, or by producing more output using the same inputs or more output with relative less inputs. Now, let's proceed on to the productivity measurement. Productivity measurement is simply a quantitative assessment of productivity changes, and its objective is to assess whether productive efficiency has increased or decreased. So the first productivity measurement is partial productivity measurement. Measuring productivity for one input at a time, and its operational productivity measure, it includes both inputs and outputs are measured in physical quantities, and as for its financial productivity measures, if output or inputs is expressed in dollar. And the formula for partial productivity measurement is output over inputs, which is also the productivity ratio. So, partial productivity measurement has both advantages and disadvantages. So, for its advantages, it allows managers to focus on the use of a particular measure. Operating measures have the advantage of being easily interpreted, therefore easy to use, provide feedback that operating personnel can relate to, and understand measures that deal with the specific inputs over which they control. And as for its disadvantages, those used in isolation can be misleading. A decline in the productivity of one input may be necessary to increase the productivity of another. And on to the second productivity measurement, which is total productivity measurement. Measuring productivity for all input at once. It requires the development of a multi-factor measurement approach, which is the use of aggregate productivity indices. Okay, now let's proceed into the profile productivity measurement, which provides a series or a vector of separate and distinct partial operational measures, and profiles can be compared over time to provide information about productivity changes. And next is profit-linked productivity measurement, which is measuring the amount of profit change attributable to productivity change. Assessing the effect of productivity changes in current period profits will help managers understand the economic importance of productivity changes. And the formula for this is current output over base period productivity ratio, which also pertains to the PQ or profit linkage rule. And onto the third one, which is price recovery component, which computes the amount of profit change from the base period to the current period attributable to the productivity changes. The difference between the total profit change and profit linked productivity change. And now let's proceed on to solving a short problem with regards to this topic. So let me read the problem to you. Manson Company has decided to install an automated manufacturing system. The decision to automate was made because of the promise to reduce the use of materials and labor inputs. After 1 year of operation, management wants to evaluate the productivity change. The President is particularly interested in knowing whether the trade-off between labor, materials, and capital was favorable. Data concerning output, labor, materials, and capital was favorable. Data concerning output, labor, materials, and capital are provided for the year before implementation and the after year. So please refer to the table below. So here are the requirements. Number 1, compute the partial measures for materials, labor, and capital for each year. And what caused the change in labor and materials productivity? And number 2, calculate the change in profit attributable to the change in productivity of the 3 inputs, assuming that these are the only 3 inputs. Evaluate to automate. So let us compute this problem in Excel. So as you can see here, I have already placed the important information with regards to this problem. So now let's proceed on to solving the first requirement, which is computing the partial measures for materials, labor, and capital for each year. So for the year before, as for materials, to get this one, again, the productivity ratio is output over inputs. So for materials, we're just going to divide the 200,000 outputs for the year before by the inputs for materials, which is 50,000. And that would give us 4. Now for labor, again, we're going to divide 200,000 outputs by its labor input quantity, which is 10,000, and that would give us 20. And for capital, we're going to divide the 200,000 output by the capital input quantity of 10,000 as well, and again, that would give us 20. And now for the year after. So for materials, we're going to divide 240,000 output by the input quantity materials of 40,000. That would give us 6. As for labor, again, 240,000 divided by the input quantity in labor, which is 4,000, and that would give us 60. And lastly, for capital, we're going to divide 240,000 output by input quantity in terms of capital, which is 600,000, and that would give us 0.4. And now answering the question, what caused the change in labor and material productivity? So, the cause of the changes in labor and materials productivity was due to the reduction in labor and material usage by using more capital output. And now let's proceed on to the second requirement, which is to calculate the change in the profits attributable to the change in productivity of the 3 outputs, assuming that these are the only 3 outputs, and evaluate the decision to automate. So for this one, if you could remember the 3-way variances that corresponds to the growth, PRC and productivity. So in computing for the second requirement, we are just concerned with the productivity component. So for this one, we're just going to compare the year after and the PQ. So let's start first with the materials. So first, let's input the quantities. So for the year after, the input quantity for material is 40,000. And for PQ, this is computed by dividing the output of the year after by the productivity ratio of materials for the by the year before. Okay, so now let's place the costs for this one. So for the year after, that is 2. Oops. That is 2. And this is 2 as well. Okay. So this is computed by deducting 40, this is computed, the variance is computed by deducting the units in PQ by the units for the year after, then multiplied by the cost, and that would give us 40,000 favorable. And now let's proceed on to the second input, which is labor. So for the year after, the input quantity for labor is 4,000, and as for its PQ, it is again computed by dividing the year after's output, which is 240,000, by the productivity ratio of labor under the year before, which is 20, and that would give us 12,000. So let's input the costs for both year after and PQ. So that is 5, and that would give us 40,000 favorable as well. So again, this is computed by deducting the PQ quantity, which is 12,000, by the year after quantity in labor, which is 4,000, and multiply by the cost, which is 5. And now let's proceed on to the last input, which is capital. So let us input the year after quantity, which is 600. And for the PQ, this is computed by again 240,000 divided by 20, which is the productivity ratio of capital in the year before. So that would give us 12. And for the cost, this is 600,000 multiplied by 15%, and that would give us 90,000. And for this one, and for the PQ, it is computed by multiplying 15% rather by the quantity, or by its corresponding quantity, which is 12,000. So that would give us 1,800. And this is computed by simply deducting 1,800 costs by 90,000 costs for the after year, and that would give us 88,200 unfavorable. So if we're going to compute for the total variance, we're just going to add these three: the 40,000 favorable for materials, 40,000 favorable for labor, and 88,200 unfavorable for capital input, and that would give us 8,200 unfavorable. So answering this one, how are we going to evaluate the decision to automate? And that is The total variance represents the decrease in profits due to changes in productivity. Looking at the numbers, the implementation of automating was not a good decision. So that is all for the final topic, which is productivity.